After we finish the DRC, we can proceed to lens matching. For lens matching, we have some requirements here on the left side. For this part, we have 4 pairs of differential lines. Previously, the error was set to 5 mils. Then for Eve, it's the signal line between U1 and U3, which is the RGB. The error here is set to 50. Then from UEZ to COM, from UE to this connector, there are 5 pairs of differential lines to this connector. These also need to be length matched, with the error set to 5 mils as well. As for the direct connections here, we just need to create the corresponding net class for them. Now, select it and right click, then choose network operations. For HDMI, how do you right click? Do you select the network and then create a net class? HDMI. Then for this one, just name it LVDS. Low voltage differential signaling. And here, let's call it RGB. That's right, pick out 7 or 8 lines, and this one is for clock and control. Then right click again, network operations. Yeah, that's it. Next, let's do this part first. Since there's a differential pair in the middle here, for length matching, what we usually do is match the lengths on the left side, or match the top and bottom separately, or add up both sides of a whole line to match the total length. Let's first look at this direct connections and match their lengths here on this PCB. Then let's check the microphone points here. Let's take a look at this part. 5 sides. This one is 64 and this is 71. 646. The longest one is this trace. But we'll leave this one as is. Also, since we're splitting here, we need to add a ground shield. So we can start by placing some wires. We need to add an elevator, so let's do that first. Here, we can just copy and paste directly. It's a bit towards the top, so here, I'll move the whole thing up for you. I'm moving it along the y-axis. That one. Just move it to this position. I'm gonna push it and take a look. Alright, same here. Let's just get rid of these conflicting parts. And let's search for it. I'll set it as a reference point. So the differences here are pretty significant, so let's adjust them a bit. For equal length, this one here is 7112.71 and this one is 60. The margin of error is set to 5.2 meters. Here it needs to be 65.7 meters, and if it's 66, that's just right. So just tweak these two a little. Just make a slight adjustment and it'll be fine because the difference between them isn't much. If you just adjust it a bit, it'll be around 69. If it's 660, just tweak it slightly and that's enough. The difference isn't much. Hey, there's 6000 here. So let's start with ours first. Alright, I'm done with this side over here. So can we arrange them? 70, 71, and then this one is 66. Next, let me briefly explain the simple part to everyone. For the LVDS here, it's the same. You also need to keep the ground shielded and the lengths matched. Then just make a mark here by hand. Let's take a look first. The longest one is about 500, and it needs to reach 8 or 900. It needs to go over 900, which is quite long. So here it needs to bend downward. If you bend it downward, we have more space available later on. Let's adjust it first. Oh, if we want the differential pairs to be of equal length, we can use this here. In the routing section, there's a differential pair length tuning tool. It automatically creates serpentine traces. Alright, let's make some changes here. This one is a curve. And this one is a chamfer, like this, chamfer edge. This is a spacing and this is a chamfer. For the chamfer, set it to 25. As for this one, the current version we have is... Let me check the width of this trace. It's usually 4.2. And because I just tried to implement it, there's this adjustment for them to be equal. So here you need to check the other options first before you can select it. Then here, select A, it's 4.2, and then 8.4, which is exactly 3W. We can take a look at what the value is. Now it's 1000. If it's 1000, that's too much, so push it over this way. This is it. If it's 970, then for the longest K, it's only 911. Add it for him. Cut it off for me. After I'm done, right click. If I keep adjusting just a part, then just right click here and ungroup it. And then this one, 997, 968, now it's satisfied. Right? And then you can only adjust it in the area that's not coupled. Then continue to make the ground holes for them. Here you also need to set the arithmetic progression for it. over 1,000 now. That's already enough. $967. 967 is about right too. Okay, close it. And here is the 8.2 harvest speed. Except for here, and then for this part, right click to ungroup. And for me, I set a shortcut key as Control plus Q. It's set here. 947, still 20 short. At this point, you still need to make the ground holes. And here, just go a bit slower. Take your time with it. You need to turn a bit here. Then give it a little shake here. It splits. $910, maybe turn it this way a bit. When I pull here, there's also a lens on the side. 806. Pull it down like this. Hey, this is 983. 983, so enough, right? If enough, press Control plus Q. Actually, 75 is still too much, so let's adjust it a bit more. Alright, 970, right? Then it's LVD SE across. This one is still 20 short. Uh, 970, 967 is fine too. That's good enough. And then this last one, this one. You can see it, right? 959, 519.66. This probably isn't enough. Take another 1.96 inches. That's what we need. And if it doesn't come out here, we can push it back in. Move it out a bit. Then I think 971. And let's shrink it a bit more this way. $967. 673. Yeah, that's pretty good now. That's done. And then this one, 496, 910, 9,950, 950, 20 short. $966, $960, $967. Let's just go with 967, and here 910, 910. We still need to compensate here. No doubt it's the same. There's traffic. Okay, if we want them to be the same length, we have to do that too. Then let's patch the ground hole here. And then now we're just left with this set of RGBs. The RGBs are in the middle because there's also a string group running through, so we need to establish that connection. As for the connection, we've already checked the AD here, create it. And when we create it, first we need to know about this part here. Which two chips are connected here? We know that one is U1 and the other is U3. And then here, design, we use the query draft to link them together. Because right now, as we can see, we can only see this half and we don't know about the other half. If we want to know the other half, we can create a class. Or when we want to make them the same length, do we just add both sides together? It's a bit troublesome. So if we create a new length port, it will directly link both sides together. By linking them directly, you can immediately see the total length of both sides added together. If we don't create a length port, then we just add both sides together manually. For equal length, it means the top is equal in length and the bottom is equal in length because it's tighter in the middle here. So if you want both the bottom and the top to be equal in length, it's definitely hard to route. So you just add both sides together and make them equal in length as a whole. If you don't create a length port, then you just handle this side separately, make a document for this side and make another document for that side. Then you compress it into one, put it into a table, and add up the lengths to make them equal. Doing it this way is a bit troublesome, so here I'll show you a more convenient method. Instead of cutting, it's easier to set up a query first and then proceed with the design. So at this common port here, create it, and then on this side, we select the class we just created, which is for U1. So here I choose U1. Then here you can write either with or without key positions, both are fine. This one is UU3. Next, select these two, and after selecting, you'll see that the U1 network appears here. Now let's take this RGB, select RTV here, and it will indicate that it's currently in this class. And this is a separate serial group, so you can select it directly. Here, analyze this, there's a down arrow inside, and here there's a device connected in series. Click on it. Since we've only selected one here, only one will appear. So after selecting it, press Ctrl+A to select all, then click on the device connected in series here and link them. If you reference it, it will automatically link them together here. Then just confirm directly. And if we look at the length in this case, check here, you need to check here. It should be visible at a glance. Then here, in all these long imports, because I hadn't created the class for it at the beginning, it's in the all section. If we delete these, just remove them. Then in this design, let's do it again from the start. U and U3. Alright, here you can just type in the class you want. For example, if you want to create something like RGB, just type RGB directly, and when you analyze it, it will automatically create it for you. It will create a class for the RGB query port, and then you can analyze it and create it one by one according to the requirements. During the linking process, this analysis will be displayed here, and then you just confirm directly. This way it will create a class. We can take a look. The longest one is 2100, right? 176. So on our side, we definitely need to find a way to bring it down. Because in the middle here, it will definitely be difficult, right? I can make a second adjustment.